Hello everyone, myself Hans. Today we are going to solve the given problem from topic a function of complex variable. Question is given here. Determine whether 1 upon z is analytic or not, analytic function or not. Let's solve the problem here. Given function is 1 upon of z. In complex variable, we know that z is given by x plus of iy, and we can also know that here I square is written as minus of 1. So we have to use this following result here. Let w is equal to f of z is a function. This is equal to u plus of iv, and this is equal to 1 upon of z. Putting the value of 1 of z here, this gives 1 upon of x plus of iy. Here rationalizing here, this gives x minus of iy upon x minus of iy, and we have to, after solving, this gives x minus of iy upon x square plus of y square. Here we have to equating the real and imaginary parts. This gives x upon of x square plus of y square and minus of I into y upon of x square plus of y square. And equating real and imaginary parts, this gives u is equal to x upon x square plus of y square, and v is equal to minus of y upon of x square plus of y square. In the following question, 1 upon z is analytic function if CR equation is satisfied, and the CR equation is given by, CR means Cauchy-Riemann equation. CR equation is del u upon del x is equal to del v upon del y, and del u upon del y is equal to minus of del v upon del x. So we have to find first del u upon del x, then we have to find del v upon del y, then we have to calculate del u upon del y and del v upon del x. If CR equation is satisfied, then we have to say that the given function is analytic. So we have to find here del u upon del x. Here is x square plus of y square, and differentiating x with respect to x, this gives 1 plus of x, and again x square plus y square differentiating with respect to x, this gives 2x upon, here is minus upon x square plus of y square का whole square. This gives x square plus of y square minus of 2x square upon x square plus of y square का whole square. So we have to get from here the value of del u upon del x is y square minus of x square upon x square plus of y square का whole square. Similarly, we have to find here del u upon del y. First we have to find del v upon del y. Del v upon del y. Del v upon del y. The value of v differentiating with respect to y here, this gives x square plus y square is taking first function x square plus y square, and the second function is minus of 1. Minus of y differentiating with respect to y, this gives minus of 1. Here is minus, and again differentiating x square plus y square with respect to y. Once again, here is minus of y, and again minus of y is already present here. So we have to once again minus of y. Here we have to use, here first we have to take a minus is outside. Minus is taking outside, and x square plus of y square is the first function, and differentiating y with respect to second function with respect to y, this gives 1 plus of y, and again x square plus y square differentiating with respect to y, this gives 2y. Here is minus, sorry, upon x square plus of y square का whole square, and from here we have to get x square plus of y square minus of, once again, here is the first function x square plus y square, and again y, second function differentiating with respect to y, this gives 1, minus of first function here y, and again x square plus y square differentiating with respect to y, here is 2y. So we have to get here minus of 2y square upon x square plus of y square का whole square, and from we have to get the value of del v upon del y is, minus is multiplying in the bracket, this gives minus of x square minus of y square and plus of 2y square upon x square plus of y square का whole square, and this gives x square minus of, once again, y square minus of x square upon x square plus of y square का whole square. Further we have to calculate del v upon del u upon del y, del u upon del y, del u upon del y. Here the value of u differentiating with respect to y, here this gives, here in the denominator the coefficient x with respect to y, we have to differentiating here, so we have to taking x as a constant, and 1 upon of x square plus y square differentiating with respect to y, this gives minus of 1 upon of x square plus of y square का whole square, and again y square differentiating with respect to y, this gives 2y, and from here the value of del u upon del y is given by minus of 2xy upon x square plus of y square का whole square. Similarly we have to find del v upon del x. Here del v upon del x, the value of v differentiating with respect to x, the coefficient x is present in the denominator, so we have to taking here minus of y is constant, and 1 upon of x square plus y square differentiating with respect to x, this gives minus of 1 upon of x square plus of y square का whole square, and again x square plus y square differentiating with respect to x, this gives 2x, and from here we have to get here minus minus plus, this gives 2xy upon x square plus of y square का whole square. Using the CR equation here, the value of del u upon del x, the value of del u upon del x is y square minus x square upon x square plus y square का whole square, and the value of del v upon del y, del v upon del y we have to calculate it once again. The value of del v upon del y is also y square minus x square upon x square plus of y square का whole square. This is satisfied, and the second is del u upon del y. The value of del u upon del y is here minus of 2xy upon x square plus y square का whole square, and the value of del v upon del x, the value of del v upon del x is here 2xy upon x square plus y square का whole square. Here is minus and here is also minus, so from the given data we have to set that the CR equation is satisfied, then we have to set that the given function is analytic. Further we can also find here once again, here we have to let w is equal to 1 upon of z, and differentiating w, the value of w with respect to z, this gives dw upon dz is minus of 1 upon of z square. This given function is also differentiable, so we have to say that the given function is analytic. Thank you class, and thank you for watching. This is the required solution of the given problem.